Introducing DynaBrush, a dynamic hair washing device designed to help Miss Liu wash her hair in an efficient manner while addressing her conditions. My name is James Park, and I'll be presenting a summary of our client and the motivation behind our device. Miss Liu stated that she has an autoimmune disorder that causes unpredictable joint pain. This makes daily tasks such as opening doors, washing her hair, and holding utensils difficult. She has trouble closing her fingers and moving her wrist. In addition, when her wrist gets swollen, she experiences pain and discomfort. She also reported burning sensations and itchiness. She has hip issues which makes walking difficult. After collecting information and requirements about our client, Team 26 generated several constant solutions and ultimately proposed a design. We wanted, we wanted to design an efficient, comfortable, innovative device that assists her in washing her hair. Miss Liu mentioned that having her hands slightly cupped causes her the least amount of pain, so we designed our device that puts her hands at comfort. With Dynabrush, Miss Liu can wash her hair without much finger and wrist movement, as the bumps resemble the fingers and the motor mimics the scrubbing motion.
Hi, it's Noel. Simplicity and functionality are the two legs upon which our proposed solution stands upon. This product and solution were designed by keeping Miss Liu's mobility constraints in mind. For Design Project 4, we decided to create a device that would enable and help Miss Liu to brush her hair in a manner that would no longer be inconvenient for her, considering the current problems that she faced due to the lack of mobility and flexibility in her fingers. We propose to solve this problem by creating a device that does the act of scrubbing her scalp and dispensing the shampoo onto her scalp for her. The way this device works is that we designed a wearable glove. This glove is easy to slip on, and on this glove, one side contains a brush. The way the brush works is that it has a motor attached to it, and this motor would cause vibrating oscillations that would, in theory, scrub her scalp for her. The other side of this wearable glove contains a reusable sponge. This sponge would store shampoo for her and would do the act of dispensing the shampoo onto the scalp, thus minimizing the amount of work that she would need to do in order to actually scrub her scalp and thus minimizing the amount of unwanted and tiring activity in the process.
This is Elena Handiak speaking. This is our initial prototype. It consists of a 3D printed comb, elastic, Velcro, and cloth. The prototype did not include a motor or waterproofing, as we planned on implementing those in our final design, since the purpose of this prototype was to convey our general idea, as well as determine if the bristles on the comb were the proper size. Our initial prototype was a very simple comb-like back. We wanted to create a basic shape so we could determine what modifications needed to be made. We determined that the bristles were properly sized and spaced apart, but that the regular 3D printing material was too hard and would cause discomfort to the scalp. The comb was modeled to have holes where the straps could go, but upon printing, we realized that it was impossible to remove the support filament from inside. So we decided to simply glue the straps on, which were made of 3 elastics. Velcro was attached to the elastics and acted to hold them all together. The cloth was meant to represent a sponge, which we would attach the Velcro to. For a later prototype, we would have to use one thicker elastic for the strap and determine how to hold the Velcro in place in a secure and waterproof way. Overall, the prototype helped us visualize our idea and taught us that our initial comb was not very comfortable. This was very helpful in creating our final design.
Hello, this is Abby Cooper speaking, and I'm going to outline the potential next steps for our device. First, we plan to implement several changes to the physical design and execution of our product. These would include a thicker elastic strap attached to the plastic device and softer bristles to accommodate for the user's comfort, as well as an internal vibration motor to reduce the need for finger mobility in the hair washing process. A high-fidelity prototype of our device would be 3D printed out of rubberized filament for a smoother finish and softer bristles. I will now show you the CAD design for this device. It contains an internal compartment that contains the the vibration motor, and all of the circuitry necessary to operate it with an on and off switch on the side. The electronics would be waterproofed with a sealant spray for safety purposes. The elastic strap attaches to the compartment lid, which is designed to fit in the hand in an ergonomically beneficial way. To test our device's compliance with our needs statement, we would first want to test on our own the hair washing to determine its efficiency. Then we could give the device to Miss Lou for her to use on her own. After this, we could collect feedback as to see if she felt any joint pain during the operation of this device. If she felt like she would have needed more strength in the distal bones of her palms to operate the device, and whether or not she felt that it was an efficient way to wash her hair. Thank you.